Alright, so given a graph, we want to identify both one-sided and two-sided limits. So what I want you to do is evaluate the limit below using our strategy that we previously learned by constructing a table of values. So notice, of course, that this is a two-sided limit. So go ahead and pause the video and do that on your own. Alright, so after making a table of values, what we see is that as we approach -4 from the left, in other words, the limit as x approaches -4 from the left of f of x is equal to 4. And if we approach -4 from the right-hand side, as we do down here, right, -3 is to the right of -4, we see that the values are approaching 15. And so we would say that the limit as x approaches -4 from the right of f of x is equal to 15. And we'll just write that down here. From the right of f of x is equal to 15. And so, of course, what we can say is that the limit as x approaches -4, the two-sided limit, does not exist. Now, I want us to think about how we could represent this function in a different way that would still allow us to understand and to calculate both the one-sided limit of this function and also then determine the two-sided limit. And what you might be thinking already is, look, when we have a function, what we're used to doing is graphing it, right? So we've constructed tables now, and that's been really useful. But what would happen if we were just to see the graph of this function? And so I want you to construct the graph of f of x, and notice that this is very simple, right? When x is less than -4, we're using the function x plus 8. So you could plug in a couple values, and look, we've already started. You plug in -5 and you get 3. And when x is greater than or equal to -4, the function is x squared minus 1. So this is a little bit of good practice, just sketching some graphs quickly. So go ahead, and you don't have to sketch them all over the place, but just near -4, let's sketch a graph of this function. Alright, so here I've constructed the graph of the function, right? To the left of -4, we are defining the function by x plus 8, a linear function. And for all values, including -4 and greater than -4, the function is defined by x squared minus 1. So the roots of that quadratic are -1 and +1, and the vertex is at the point 0, 1, or sorry, 0, -1. And so notice that the only real kind of tricky thing here is to make sure that we have the open point along the linear function and the closed point along the quadratic, because when x is greater than or equal to -4, so that means that at -4 we're defining it with this function here. And once we have the graph of the function, and if we're given the graph of the function, I think you'll find that it is very straightforward to determine the limits. So let's again approach this question here, the limit as x approaches -4. And so, of course, if we want to determine the two-sided limit, we're going to look first for the one-sided limits. So as we approach from the left, notice that the function is increasing as we approach from the left, and as we approach -4, the function is getting closer and closer to the value of +4, just as we saw when we constructed the table. So if we're given the graph, it's even easier perhaps to see because we don't have to do all this work to compute those values. So the limit as x approaches -4 from the left is 4. Now as we approach -4 from the right-hand side, so if we start to the right of -4 and follow our graph, we see that we are going to hit the vertex and then climb until we get to the point 15, right, to the value 15. And you'll notice that as we're getting closer and closer to -4, the function is getting closer and closer to the value of 15. In fact, we could actually plug in -4 into this function and see that it is exactly 15 at -4. So as we approach, negative 4 from the right-hand side, the value of our function must be approaching positive 15. And so this allows us to compute the left-hand and right-sided limits of f of x, see that they are different, and therefore conclude that the two-sided limit as x approaches negative 4 of f of x does not exist. All right, let's take a look at another example. Okay, consider this piecewise function f of x graphed over here, and determine the following three limits as well as this value of the function. Give this a try on your own, and then we will go through it step by step. All right, so hopefully you realize that having a graph of the function makes our job a lot easier. We can just use the graphical representation to go through and figure out each limit. All right, so hopefully by now we're seeing that the process really is the same regardless of whether we're using a table or a function, but using, if we have a function, it's actually less work and probably a little easier at least to visualize certainly the limit of the function. So as we approach 0 from the left-hand side, our function appears to be on this what looks like a quadratic path, and so as we are getting closer and closer to 0 from the left-hand side, the function appears to be getting closer and closer to this point here, so it's getting closer and closer to a value of 2. So the limit as x approaches 0 from the left of f of x is equal to 2. All right. Now, as we approach from the right-hand side, as we are coming in from the right, we are on this linear part of the graph, and as we move closer and closer to an x value of 0 from the right-hand side, we're getting closer and closer to this point here, which has a value of negative 1, so the function is approaching a value of negative 1, and thus the limit as x approaches 0 from the right is equal to negative 1. And so to determine the two-sided limit, we can just recall that the definition of a two-sided limit involves the one-sided limits. And if the one-sided limits exist, as they do, and are equal, then that is the same value for the two-sided limit. But since the one-sided limits are not equal to each other, the limit, the two-sided limit of f of x does not exist. All right, now we want to determine the value of the function at an x value of 0. What is f of 0? And so looking at our function here, we notice that when the x value is 0, our function is defined by this closed point here, and so the value of f of 0 is negative 1. All right, let's take a look at one more example. All right, here we have the same piecewise function, f of x, but we're determining some slightly different limits and values of the function. No need to copy down this function again, you should already have it. So just go ahead and copy down these new limits that we're finding. Go ahead and give them a try on your own, you should be just fine, and we'll debrief the answers quickly. Okay, so first off, we're approaching 3, an x value of 3 from the left, and so we can see that we're traveling along this part of the function, this linear part of the function. And so as we are getting closer and closer to the x value of 3 from the left-hand side, we are traveling up and approaching this point here, which has a value of 4. So the limit as x approaches 3 from the left, it's approaching a value of 4. Similarly, as we approach 3 coming in from the right-hand side, we're on this linear part of the function, and as we move closer and closer to an x value of 3, we can see that our function is getting closer and closer again to a value of 4. So the limit as x approaches 4 from the right of f of x is equal to 4. And so this informs the two-sided limit, because both one-sided limits exist and are equal to the same value. So intuitively, this should make sense. The two-sided limit is definable, it does exist, and its value is 4. Right? And this is very clearly shown in the graphical representation, right? both parts of the function to the left and to the right of 3 are approaching the same value. And so it would make sense that the two-sided limit is both does exist and is equal to the values of the one-sided limits. Now, lastly, we have the function at the next value of 3. And so f of 3, interestingly enough, is not the same as the limit as x approaches 3. And this should make sense based on this graph, right? F of 3 is in fact defined here by this close point and has a y value of 1. So f of 3 is equal to 1. And so this is a good lesson that we can't always say that the limit as x approaches 3 is the same as the value of the function at 3. And that's important to note here, particularly with piecewise functions like this. And so we need to stick to our definition. When finding a two-sided limit, we find the left side and the right side limit, and then use those two to determine first whether our two-sided limit exists, and then if it does, use that value from the one-sided limits as the value of the two-sided limit. All right, I have one for you to try on your own, and we will debrief when we meet again together. All right, so choose the correct answer and justify your answer in complete sentences. So a couple of notes here. Make sure to copy the graphs into your notes. You want this question readily available. It'll be a good review at some point, certainly. And also make sure that you are justifying your conclusion. So we want to get in the habit of writing these really solid supporting statements for our conclusion so that we're maximizing our score on the AP test. And what we'll do is we'll share out our viable arguments, if you will, in support of our conclusions. And so we can kind of see, what is the best way of supporting our conclusion so that not only are we getting the correct answer, but we are doing the best job of convincing someone that it is in fact the correct answer.